Right. So you have 9 divided by 2x plus 6 equal and then 2y times x plus 3. All right, so remember, you want to find what that numerator should be. So you want to find out 9 divided by 2x plus 6 is equivalent to what fraction with that denominator. So what are you going to do first? Well, no. Because you know what they want. They want this denominator right here. But what I was hoping you would say is factor this denominator. Okay? Factor. So when I factor this, that's going to be 2 times what? X plus 3. Okay. Now, this is what I have. This is what I want. So what is it I got to multiply this denominator by to get this that I want? What's missing? The y. So you're going to say times y. But what I do to the denominator, I do to the numerator. So this right here goes here. So what's this? 9y. So you would say the numerator has to be 9y. Okay? Let's suppose you had, let's suppose you had this one. 3 divided by 9y to the 5th. I'm sorry, wrong one. 6 divided by 3a equal, and then this denominator is 12ab squared. So 6 divided by 3a is equivalent to what fraction with this denominator? Now, notice when we did the previous example, we factored first. But these denominators are monomials, so there's no factoring involved. So you just got to ask yourself, I have a 3a, this is what I want. So how do I go from 3a to this?
4b squared.
Multiply by 4b squared. Because all right, so because 3 times 4 is 12, right? And then b squared. So I got to multiply this by 4b squared. But what I do to the denominator, I do to the numerator. So this goes here. So what do I write? 24b squared. All right, so that's what we talked about last class period. Now, one thing we didn't talk about is this. Okay, so listen carefully. So this is going to be number, and find one, okay, this will be number 34. Okay, listen carefully to this. Now, the directions are different from these. Here, the directions were find what the numerator needs to be. We did. Here, the direction says, remember, it's going to say this. Okay, now before we do this one, let me go back and talk about this. Let me write this example. All right, so don't look at this just yet, or don't attempt to do this just yet. Listen to this. Suppose I had x plus 1 divided by x minus 2, comma, 3 divided by x plus 3. Okay? And all the direction says for this one is this. Find the least common denominator. Remember, it says the least, not a common denominator, because there's an infinite number of common denominators, but there's only one least. What is the least common denominator for that? For this right here? 1?
6.
Okay, you gotta remember something we talked about last time. The least common denominator has to have every factor. What's the factor in that first fraction in the denominator? Huh? X minus 2. So x minus 2 better be part of the LCD. I forgot about that. What's the other factor in that other fraction in the denominator? X plus 3 better be part of the denominator. So what's the LCD? X minus 2 times X plus 3. Now that's going to be important with what we're about to do now. We're starting the next section in a little while. So you already forgot how to deal with this. Now, look at this. Can I factor anything here? No. For the most part, I can't. The GCF is 1 in both of those. So you may say this, which is going to be wrong. You may say that the LCD is 3x minus 7 times 7 minus 3x, right? Incorrect. LCD is not 3x minus 7 times 7 minus 3x. It's not like this one. And here's why. They're opposites. They are opposites. 3x minus 7 and 7 minus 3x are opposites. So since they're opposites, here's what you have to do. I'm going to rewrite this over. It doesn't matter which one. It does not matter. But whichever one you pick, I'm going to go ahead and pick this one here. Whichever one you pick, you're going to rewrite this by factoring out a -1. Remember when we first started about factoring in chapter 6? One of the directions says, one set of problems says factor out a -1. That's why you had those kind of problems for situations where you dealt with opposites. If I factor out a -1, -1 times what's a positive 7? -7, which is what you see here, right? -1 times what is a -3x? Positive 3x. So do y'all agree then that 7 minus 3x is the same thing as saying -1 times 3x minus 7? Okay? Right? Okay. Which is this right here. You see it? Then the next thing you're going to do is this. Next thing you're going to do is this. You remember when we simplified and there were opposites, numerator and denominator, we crossed them out, we tended to put the denominator as factor 1 and the numerator as a factor of -1. What I would do with this is I'd bring in the top and make the 5 what? -5. So notice this right here becomes -5 divided by what? 3x minus 7. And so now, what do you notice about those two denominators? They're the same, so what's the LCD? 3x minus 7. Okay? You could have also said the LCD was what instead? 7 minus 3x. It did not matter which one. Because you could have done this. You could have said, all right, instead of factor out the -1 from this one, I could have factored out from where? That one, right? So I'm going to go ahead and rewrite it. So I could take out a -1 here, and that would be -1 times what's 3x? -3x, keep that in mind, -3x. -1 times what's a -7? Positive 7. So you don't agree that this right here is the same thing as saying -1 times 7 minus 3x, which is the same thing as this one. And let's bring the -1 out on top. So I'm going to write it like this now. This right here is -1 times 2x plus 5 divided by what? 7 minus 3x. So now those are the same. So what's the LCD? So the point's this. When they're opposites like that, and you can see this in my math lab. So I'm bringing this up because this will be on my math lab. Since those are opposites, you could have said the LCD was 3x minus 7, or you could have said what? 7 minus 3x. It did not matter since they were opposites. But notice why we said either one, because When I factor the negative 1, I just brought the negative 1 to the numerator instead. Okay? All right, so on my math lab, when you get to that one, something like that, just be aware it is not 3x minus 7 times 7 minus 3x. You're going to get it wrong. You got to recognize that those are opposites. Here, it is x minus 2 times x plus 3 because those are not opposites. But these are opposites, so don't say this. It's either going to be this one or this one, but know why. It has to do with that negative 1 that you factored out. You can bring it to the numerator in either case. All right? So in my math lab, you're going to see this. I don't think I had one like this on a test. Well, I don't have it on a test. But it could be on a worksheet. I don't think I did, though, on this one. But if it is on a worksheet, that's what you do. Okay? All right, now, when we get into the next section, there is going to be a couple of problems, probably in my math lab, where you have to deal with the opposites from the denominator. But we'll go over it again. Okay, but that's all this was. It's not difficult. The other thing you had to be careful of was this. So let me just remind you about this. Two x plus 3 divided by x squared minus x minus 30 minus x minus 2 divided by x squared minus x minus 30. Okay. So remember, when we talked about that, all you're doing here is subtracting those two rational expressions. When adding or subtracting rational expressions, what did we discuss?
You have to bring the x minus 2 on and change.
Okay, we did discuss that, but then that's true. We are going to talk about that, and that's one of the things that we're going to bring up. But when adding and subtracting rational expressions, your denominators have to be the same. Okay, in this section they are. The next section, in a little while, they're not. But they are here, right?
Right.
So once they're the same, then you can write as one rational expression. So in other words, this becomes what denominator, though?
X squared minus x
Minus 30. And then you just write the numerators up here. So this becomes 2x plus 3. Now, the other thing we talked about was when you're subtracting a monomial, it's easy. You just subtract that monomial. But this is not a monomial. So you got to be careful. It's kind of like you're distributing that negative 1 through here. So you're subtracting each of those terms. So this, when I subtract this numerator, this really becomes what?
negative x
Plus 2. Okay, good. That's what we talked about last time. Now let's combine like terms. What's the numerator? X plus 5 divided by x squared minus x minus 30. So that's where we're at. Is that the answer?
No.
No, because you have to simplify. And to simplify that, you have to do what first? Factor. So that goes back to section, what chapter 1, 14? That goes back to section 14.1. So can I factor the numerator? No. Can I factor the denominator? Yes. So when I factor the denominator, xx, 5 and 6, 6 has to be negative, 5 has to be positive. And what do you notice?
The x plus 5 is
Divide out. Now, don't just cross them out like this. You got to put what's in their places. 1. And so what's the answer?
1 over
Over x
x minus 6.
minus 6. Okay, so that's all stuff we talked about last class period that you're going to need in the next section. All right, now let's talk about the next section. All right, it's not that difficult. Let's look at number 2. So this is going to be on page, so this is section 14.4. And this is, remember, 14.3 was where we added and subtracted rational expressions with like denominators. This is where you're adding, subtracting rational expressions, and these are going to be unlike denominators. Okay, so those are going to be unlike denominators. All right. We're going to start with an easy one. This is number 2, and that's on page 1065. Okay, now listen to the process. When adding or subtracting rational expressions, before I can combine them into one, what must happen? Denominators have to be the same. Are those denominators the same? No. So then I have to find the what? Least common denominator. Before I find the least common denominator, I've got to factor the denominators. Okay? So step 1 would be factor the denominators. Now, let me just say this first. This would be step 1 for adding, subtracting rational expressions with unlike denominators. So step 1, factor the denominators. Can I factor these? No, because they're what? Monomials. Okay, but if I could, I'd factor. Step 2, find the LCD. All right, so let's talk about that. Do the coefficients first. Was the smallest number, remember I said LCD, don't just pick any common denominator. And for these, you got to use the LCD. If you use a common denominator, you'll get the right answer at the end, but you have to use, I want you to use the LCD. So you're not going to get full credit if you don't use the LCD. What's the smallest number that 7 and 6 go into? 42. So far my LCD here, I'm writing right here, is 42. Now remember how we talked about this in the last section. So always check yourself. My first factor I see is what? 7. Does 7 go to 42? Yes. The next factor I see is what? 8. How many factors do I have here? 1. How many factors do I have here? 1. So how many do I need? 1. So I need an 8. Okay. My next factor I see is a 6. Does 6 go to 42? Yes. My next factor is an 8. Does 8 go into 8? So it's the LCD. 42A. That's your LCD. Step 3. Write equivalent fractions. Write equivalent fractions. That's the part that we did at the beginning in terms of review. Is this right here. That's where you wrote equivalent fractions. That's what this was. Okay? So notice, I want these two denominators to have what denominator instead? 42a. So you say you're going to rewrite this with 42a like this. And now that looks like the one we did at the beginning of class. I'll have 7a. What do I want? 42a. So what do I need to multiply 7a by to get that? 6 times 6 times 6. See this? So what I do to the denominator, I do to the numerator. So what did I got to? So when I multiply 6 times 15, what do I get? Use your calculator. What is it? 90. So 15 divided by 7a is equivalent to what fraction? 90 over 42a. Now it's equivalent to an infinite number of fractions, but it's only equivalent to this when the denominator is 42a. And then you do the same thing for the next one. 6a times what is 42a? What I do to the denominator, I do to the numerator. 8 times 7 is 56. Now can I write them as one fraction? Yes. So this becomes something divided by 42a. So your calculator, or actually you can look at this and tell me what it is. 90 plus 56 is what? 146. Okay, 146. So that's where I'm at. Okay? Notice the process. So I did step 3. Step 4 is to simplify. Now, simplifying takes several forms here. I could factor first and then reduce. But can I factor anything here? Factor. No. But I can reduce 146 and 42, right? They're both divisible by what?
73.
But they're both divisible by 2, correct? So 146 divided by 2 is 73. 42 divided by 2 is 21. So that's 21A. So there's your answer. So that was number 2. Okay? All right. Let's look at this one. So this is going to be number 6. Number 6. All right, number 6, you have 14 divided by 3x squared plus 6 divided by x. Step 1 is to factor the denominators. Those are monomials, so I'm done, right? Step 2 is to find the LCD. What do you think the LCD is? 3x squared. Not 3x. See, if you set 3x, you need to ask yourself, first of all, does 3 go into 3? Yes. Does x squared go into x? No. We talked about that last class period. So what we said was this. How many factors of x here? 2. How many factors of x do I have here? 1. How many do I need? 2. You take the larger exponent. So it's supposed to be the LCD. 3x squared. Now, x squared goes into x squared? Yes. Does x go into x squared? Yes. So once I find the LCD, the next step is to write equivalent fractions. So now I'm going to write 2 fractions with what denominator? 3x squared. Three x squared, and I want 3x squared. Well, those are the same. So basically what's happening is that if you look at this, 3x squared times 1 is 3x squared, right? So I'm multiplying this and this by 1, so that means the numerator stays the same. So that's 14. Look at the next one. What do I need to multiply x by to get 3x squared? 3x. So times 3x times 3x. So 6 times 3x is what? 18x. Once you write equivalent fractions, what's the next step? Simplify. Now, maybe I should have said this, because if you look at the previous one, before I simplified, which one? Oh, it was right here. I'm sorry. I wrote as one fraction, right? So let me just say this. Let's do this. Step 4, write as one fraction. Sorry. And then step 5 would be to simplify. Okay? So step 4 is to write as one fraction. That means I can write this now as one fraction. What's going to be my denominator? What's going to be the numerator? Nope, 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 nope. You can't combine those. Those are not like terms. 14 plus 18x, or you can say 18x plus 14. Does not matter. Okay, don't say 32x. It'll be 32x, that was 14x, right? 14x plus 18x is 32x. But that's not 14x. So that's it. That's all you can do. You can't factor the numerator. Remember, simplify? So simplify, remember, we said involved factoring, then reducing. The numerator, can I factor anything out of the numerator? 2? Okay. Is that going to help, though? So in your mind, you can think about this. If I factor out the 2 from the numerator, is that going to help me to reduce? So leave it like that. Okay, so I'm going to say it again. You can, if you want to, factor out the 2. Put an R here. And what is that going to be? 9x divided by 3x squared, right? And then the next step would be to reduce. Is that going to help? So it does not matter whether you write it like this or like this. It does not matter. Okay? Now we're going to do one where when you factor, it does reduce. But the idea is to factor next. To simplify, the simplifying part is to factor and then reduce. But factoring is not going to help here because nothing reduces. The whole point of factoring is to help you to reduce. The whole point of factoring. Just like we did in section 14.1. Remember we did section 14.1? You had to factor and then reduce. That was the whole point of reducing was to, the whole point of factoring was to reduce. So it doesn't matter which one you use. Okay? Let's look at number 8. Number 8. All right, look at number 8. You have 8 divided by x plus 4 minus 3 divided by 3x plus 12. All right. So 8 divided by x plus 4 minus 3 divided by 3x plus 12. Step 1 is to factor the denominators. Can I factor the denominators? Yes, I can factor the second one. So right underneath here, I'm going to put 3 times what? X plus 4. You all agree? Yes. So that was step 1. Step 2 is to find the LCD. What is the LCD? 3 times x plus 4. Because remember, you go through your factors. My first factor I see is x plus 4. So it's got to, how many x plus 4s do you have here? 1. How many x plus 4s do you have here? 1. So I need how many? 1. The next factor I see is a 3. How many factors of 3 do you see here? None. How many do you see here? 1. I need 1. So there's your LCD. Next step is to write equivalent fractions. So you can write 2 fractions with that denominator. But don't forget, this time you're not adding, you are subtracting. Okay. This is what I have. This is what I want. So what is it got to multiply x plus 4 by to get the LCD? 3. So 3. What I do to the denominator, I do to the numerator. So this becomes what? 24. Okay. This is what I have. This is what I want. Notice those are the same. So this has to be what? 3. Once you find the LCD, once you write your equivalent fractions, the next step is to write as one fraction. So what's going to be the denominator? Okay, now the numerator is 24 minus 3, which is 21. So that's where I'm at. Next step is to factor if you can. Can I factor anything? No. Can I reduce? Yes, because of 3 and 21. So this is 1. This is what?
7.
So what's the answer? 7 divided by x plus 4. That's the answer. All right, now let's look at 14. 15 divided by y minus 4 plus 20 divided by 4 minus y. Okay. Step 1 is to factor. So if you look at this, though, right off the bat, you can't factor per se, but you do know that they're what? Opposites. So you can use the idea we talked about earlier. So you factor out the -1, and let's do it from this one, because I prefer to have the variable listed first. So since variables listed first here, let's do this one. So I can write this one as -1 times what? -1 times what? So that's -4 plus y. So that becomes -1 times y minus 4, right? Okay. Now since this is a -1, let's just bring this to the numerator. So we write this now. We write this as 15 divided by y minus 4 plus a what? -20 divided by what? And you're almost done. Now kind of write, now guys, do I have to find the LCD? No, because the denominators are the same now. Denominators are the same. So that brings us back to the previous section. I just write as one fraction. So my denominator is y minus 4. What's the numerator? -5. And you can't do anything else. You're done. -5 divided by y minus 4. Okay, now let me just kind of discuss several ways you could write this. You see how I wrote the numerator as a -5? Do you understand that that's the same thing as saying this with the negative out in front? Right? Okay, just wanted you to be aware of that. All right. Now let's suppose for some reason you did not recognize that those were opposites. Okay? And so you decided wrongly, but you decided to say that the LCD was, I'm going to go ahead and use another sheet of paper, but you decided that the LCD was y minus 4 times, y minus 4 times 4 minus y. Let's just see what happens. Okay, watch carefully. So I'm going to rewrite the problem, put this as 14 star. All right, so let's suppose you said, I'm going to say this is the LCD. Okay? Now, we know that's not the LCD, because remember, the LCD is the least. Now, this is a common denominator, by the way, but it's not the least, because the least is either y minus 4 or what? 4 minus y. That would be the least. But let's suppose you found a common denominator. So I'm not going to put the least common denominator here. I'm just going to say that's a common denominator, because we know that's not going to be the least. That is a common denominator. So you could use a common denominator here. All right. And so we write equivalent fractions. So I'm going to have two fractions with what denominator, though? Y minus 4 times 4 minus y. Okay? All right. This is what I have. This is what I want. So what do I need to multiply this by? 4 minus y. Okay, you see what I did? This has to be multiplied by what? 4 minus y. Over here, I have 4 minus y. What do I need? Y minus 4. See how I wrote it? I put that in parentheses, because both y and a -4 has to multiply by what? 20. Both 4 and a -y has to multiply by what? 15. Now I distribute. 15 times 4? 15 times a -y? Okay. 20 times y? And then 20 times a -4? -80. Now can I write as one fraction? Yes. Okay, now watch. Let's add these two. Adding's easy. Subtracting, you need to be a little bit careful. Negative 15y and 20y is what? 5y. 60 and a negative 80 is what? Negative 20. So that's where I'm at. Okay? Next step was to simplify by factoring. Can I factor the numerator?
Yes.
What can I factor out? 5. Okay. What can I do? The y minus 4 is divided out, so I'm going to end up with 5 divided by what? 4 minus y. That could be another answer. Notice, though, I want to show you something. See how we got negative 5 divided by y minus 4?
Mm-hmm.
That's because we said the LCD was, we factored out the negative 1 from this one. But if I had factored out from this one, the y minus 4, I would have gotten this answer. Okay, watch. Okay. So in other words, instead of factoring out the negative 1 from here, let's factor out from here. This is negative 1 times what? 4 minus y. That's what this is. So the LCD, I'm going to, I'm going to take this negative 1, put it in the numerator this time. Okay? So it becomes negative 15 divided by what? Four minus y. The numbers are the same, right? So I can write as one fraction. What's negative 15 plus 20? 5, and that's what this was. So it's easier, it is easier that if they're opposites, to actually find the LCD rather than just finding a common denominator. But do you understand that if you did not recognize that those were opposites and use a common denominator, you can still get the same answer? Now, I wouldn't mark anything wrong. I prefer you use a least common denominator because there are going to be some examples that are going to say, what is the least common denominator? But when doing these, there's nothing wrong with using a common denominator because you still get the same answer. It just makes it a little bit more complicated for you. It's always easier to use the least. You see how easy it was if you use the least rather than a common denominator?
Less work.
Yeah, less work. All right, so that was 14 several ways you can do it. Let's look at, all right, let's look at 26. 26. Negative y plus 1 divided by y minus 2y minus 5 divided by 3y. Sometimes the LCD is easy to find, sometimes it's not. That one's easy to find. Why is that an easy LCD to find? Because the denominators are monomials, so there's nothing to factor. So what's the LCD? 3y. That's the LCD. 3y. All right. Now, listen to how you're going to do the next step, though. You remember when we did this one, where we found a common denominator here? We had to use a distributive property, so I put those in parentheses. Okay. Keep that in mind. So the LCD is 3y, right? So I'm going to write two fractions with that denominator. Let's do this one. This one's already easy to deal with because the denominators are what? So this has to be what? The same. So the numerators have to be the same. All right, let's talk about this one. I have a y, I want a 3y. So what's missing here? I need to multiply this by what? 3. What I do to the denominator, I've got to do to the numerator. Now be careful. Everything that's in the numerator has to be multiplied by what? 3. So let's put that in parentheses, which means I have to use what property now? Distributive property. Okay, so that's why we did this one. I had to put that in parentheses because when I discussed it, I said this. So I need to multiply this by 4 minus y, but 4 minus y had to be multiplied by what? 15. So everything inside that parentheses, 4 minus y, had to be multiplied by 15. So that was a distributive property. Same thing here. That's the idea. So when I distribute, though, what does this become? Negative 3y plus 3. Okay, so that's where I'm at. So far, everything's fine. I found my equivalent fractions. Now, since the denominators are the same, I can write as one fraction now. Now, that's where you have to be careful because you're subtracting something that's beyond a monomial that has more than one term. All right, so let's go ahead and actually do the steps. You're going to say negative 3y plus 3 to actually do the step. When we did the addition, we just combined like terms. Don't combine like terms here because this is what's going to happen. You're going to say 3 and a negative 5 is a negative 2, but that's not correct. It's not negative 5. This is going to become what? Positive 5. So actually do the next step. So you're going to subtract all of these. So that becomes what? 2y plus 5. Now combine like terms. What's the numerator? Plus 8 divided by, can I do anything else? Nope. I can't factor the numerator, and there's nothing that reduces. Now don't make the mistake of reducing these y's. You can't. You can only reduce factors. Is y a factor of the numerator? No. There's only one factor in the numerator. What is it? Negative 5y plus 8. That's the factor that's in the numerator. Okay? So there's your answer. Now, someone else could have written like this, though. Instead of saying negative 5y plus 8, they could have said 8 minus what? 5y divided by 3y. It does not matter. That does not matter at all. And let me just say this. Remember how, you see how this right here is a negative 5y plus 8? All right. A while ago, see right here where we see this right here? Where we put the negative out in front? I just want you to be aware of this. Now, it doesn't matter how you write this, but if this is multiple choice on my math lab, this could also be an answer. Let's put a negative out in front. Okay? If I do that though, you got to be careful how you write the numerator. I'm putting the negative out in front. So instead of saying negative 5y, I got to put what here? 5y. Instead of saying plus 8, I got to put what? Minus 8 over 3y. Now, this is the same as all these. Okay? But on paper and pencil, either one of these is fine. But I do need for you to recognize that if you put the negative out in front, this is what the numerator would have to be. It kind of goes back to this. It's the same as what we did here. See how if I cover this up, how this right here looks like this? You see it? So when you rewrite it, this becomes negative 2y and then what? Plus 5. So you see negative 5y and then what? Plus 8. All right, so make a connection between some stuff that you're learning. (28). You have 7x divided by x minus 3 minus 4x plus 9 divided by x minus 3. What do you notice? The numbers are the same. So that actually goes back to the previous section. Can I write one fraction now? Yeah. But I'm subtracting more than one term. So you got to be careful. So let's actually write it out. There's a 7x, and then what does that become?
7x minus 4x minus 59.
Yep. All right, now combine like terms in the numerator. What is that? 3x minus 9 over x minus 3. Okay, what else can I do? Factor the numerator. What is that? 4x minus 3. And then what happens? Reduce. And what's the answer? 3. That's the answer. All right. All right, question at this point. I think I forgot to bring those worksheets. Oh no, I think I have it. Hold on. All right, so listen carefully. Part A, add, subtract. What is about the denominators? They're different. Okay, so if you find the LCD, right? And now I want you to find the LCD. Don't just find any common denominator. Find the LCD. There's a back page. What do you know about these? They're opposites. So I need for you to use the least because it makes things a lot easier for you. Okay, use the least. Okay, so that's part A. Okay, in part B, when you see something like this, you see where you have 2 plus x over x plus 5? Write 2 as 2 divided by 1. What's the LCD? Okay, x plus 5. All right. Factor, before you find the LCD, factor, and then factor. Okay? All right, so let me go ahead and let you get started on this. So work on this. You have plenty of time to do this because what's going to happen next class period is this. These were adding and subtracting rational expressions, correct?
Yeah.
Now what's going to happen next class period is we're going to start solving rational equations. Rational equations. So before you can do that, you have to know how to find the LCD. When we get to that part, you're going to multiply both sides by the LCD. And you understand what's going to happen when we get to it. But you have to be able to do this before you can move forward. And then that's going to be the end of this chapter, and then we're going to start radicals. All right. So let me get started on this, and then you can work with each other. But you got to make sure